All right, so now we're going to take what we have learned about all types of exponents and bases and put them all together in more advanced problems. So when I look at this first one, the first step is to identify, do I have negative exponents? And I see a ton. I actually see every single one of them is negative. I also see that I have two different bases. I have a base of 2 right here, both in the numerator and the denominator, and I have a base of 5. So step number 1 is to move any negative exponents to the opposite of the fraction bar, which we just learned. So I need to move these. So my 2 to the negative 5th is going to come down and become 2 to the positive 5th. 5 to the negative 4th is going to move down and become 5 to the positive 4th. My 5 to the negative 6 in the denominator is going to move up and become 5 to the 6th times 2 to the negative 2nd is going to move up and become 2 to the positive 2nd. Now, if it helps you, because if you remember from the other week, I cannot combine and add and subtract exponents with unlike bases. Think about combining like terms. If it helps you to rewrite this so that your like terms are lined up, you can do that. So what I mean is if I leave 5 to the 6th times 2 to the 2nd, I can rearrange the denominator because multiplication is flipped both ways. 2 times 5 is the same thing as 5 times 2. So I could rearrange it so that it looks like this, so that my like terms are directly right underneath each other. So now that I have my like terms all set up, I can't combine anything in the numerator and the denominator. There are no like terms in the numerator. There are no like terms in the denominator in terms of my bases. I can, however, divide because I have like bases. So when I'm dividing like bases, I subtract my exponents. So this is going to give me 5 to the 6 minus 4 is 2, second power. I can right here, since I have like bases, divide. My base stays the same, and I subtract my exponents, 2 minus 5. Notice 2 minus 5 is negative 3. I'm taking more away. All right, so technically this is simplified, but it's not in its correct form. I have this negative exponent. So my last and final step, 5 to the 2nd stays where it is since it's a positive, but I need to make my negative 3 exponent positive by moving it into the denominator. So 5 to the 2nd power divided by 2 to the 3rd power is my final simplified answer. Lots of steps, lots of little things to take into consideration. Now to go back real quick, if I were to not do and rewrite this part with my like bases, you can still do it the same way. You can say, all right, I need to divide with my 5, my bases, so I'm going to worry about those exponents, my 6 and my 4. So 6 minus 4 is 2, 5 to the 2nd power. Then I'm going to do my bases of 2's. 2 minus 5 is negative 3. So you can do it like that. However, if it helps you to arrange it like on the right, so my bases are lined up, my common bases, that's fine. Either way, whatever way you understand and you see better, you do that. Okay, so take a minute and write this one down. Pause if you need to. So the first thing I want to do is identify my negative exponents. So I see that I have a few. I have 3 to the negative 2nd in the numerator. I have 7 to the negative 8th in the numerator, and I also have the same base 7 to the negative 2nd in the denominator. My others are positive. I'm not going to circle those. So now I need to start rewriting the problem. Just like we would do with equations, if we're not using a number or a term, we're going to rewrite it. So 7 to the 5th is going to stay in my numerator. I'm going to rewrite that. 3 in the denominator is going to stay there. Remember my invisible exponent, it's going to be a good idea to write that it has a 1. Okay, now I can start moving them. So 3 to the negative 2nd is going to come down to the denominator. So times, which means when I move it, it'll be a positive 2. 7 to the 8th is also going to move down to the denominator, times 7 to the 8th. And then 7 to the 2nd, negative 2nd, is going to move up top and become positive 2nd. So I can also double check in my original problem, I had 1, 2, 3, 4, 5 terms, 5 numbers. And when I rewrote it, I have 1, 2, 3, 4, 5. So I know that I didn't leave any out. Now I need to simplify my numerator and my denominator because there's a lot of terms on both of them. So when I look at the numerator, I see that I have like bases of 7, so I can combine. I'm multiplying with these like bases, so my base is going to stay 7. That means I'm going to add, since I'm multiplying, I'm going to add my exponents of 5 and 2, so I get 7 to the 7th power as my numerator. Now, my denominator, I have different bases. I do have common bases of 3, but I have this 7 to the 8th power by itself. There's no other bases of 7 in the denominator, so I'm going to rewrite that as 7 to the 8th. I can't combine it with anything in the denominator. I do have 2 like bases of 3, and I'm multiplying. So again, when I'm multiplying with like bases, I add my exponents. So this is going to be 3 to the 3rd power. That's why it's so important up here to write your 1 as your exponent so you don't forget to add that in. Okay, now I see that I can still simplify my answer because I have like bases of 7. This 3 to the 3rd power in the denominator is going to stay there because I have nothing to combine it with. And it's positive, I'm not going to move it, I'm going to leave it where it is. Now, I subtract my exponents with my 7 base because I'm dividing. 7 to the 7th power minus 7 to the 8th power. So 7 minus 8, that's going to give me 7, but 7 minus 8 is negative 1. So that means that I need to move this 7 to the negative 1 down to the denominator, and then our 1 is just going to be our numerator. Remember, if I just have a negative exponent, when I move it to the denominator, the 1 was the numerator, and that's back in the last video. So this is my final simplified answer. I don't have any negative exponents. I don't have any other like bases to combine. That is my final answer. I could put the first power right there, 7 to the 1st power, but you're going to see it as just 7 without that invisible 1. Okay, take a moment and write this one down. Okay, so I see a couple things. First, I see exponents that I'm going to identify. I want to move all of my exponents that are negatives to make them positive. So I'm going to leave this first term just the way it is. 9 to the 2nd power. That whole thing is being raised to the power of 3. Now, I see that this 9 to the negative 4th, I'm going to rewrite it down in the denominator to make it positive. And this 9 to the negative 2nd is going to come up to be my numerator. Here I have all like bases, which is awesome. So going back to the other week, now I need to simplify my numerator. I've got a couple things I can do. I see this right here. If we remember this power to a power, when I have a power to a power, exponent to exponent, I multiply. So this is going to become 9 to the 6th power. 9 to the 2nd power raised to the 3rd power is 9 to the 6th. Rewrite everything else. I can still combine. My numerator, I'm multiplying with like bases, so I add my exponents. So 6 plus 2 is 8, so I get 9 to the 8th power over 9 to the 4th power. Like bases, my last step, since I'm dividing, is going to be to subtract my exponents, and 8 minus 4 is 4, so 9 to the 4th power is my final answer. As always, pause whenever you need to make sure you've got all this down so that you can refer to it when you get to your own practice. Okay, last one together. This one is a little harder because I have different bases. I don't have all the same. First, identify. I do have negative exponents. I'm going to rewrite my positive exponents. 7 to the 2nd power is going to stay in the numerator. In the denominator, 7 to the 4th power is going to stay in the denominator. I do not move positive exponents. They stay where they are. 2 to the negative 3rd is going to come down to the denominator. 2 to the positive 3rd, and 2 to the negative 4th is going to go in the numerator. I cannot simplify the numerator, and I cannot simplify the denominator. They are not like terms in the numerator-denominator. I can, however, since I'm dividing with like bases, I can, however, go ahead and simplify that by subtracting. So I have like bases of 7. So 2 minus 4 is a negative 2, because I'm taking more away, times my base of 2, subtract, since I'm dividing, 4 minus 3 is 1. My last step, 2 to the 1st power is just 2, and it's positive, so it's just going to stay there, over, I need to move this into the denominator to make it positive. So 2 over 7 to the 2nd power is our final answer. Take a moment, write this one down, and try this on your own. So pause in order to have time to do this. Okay, so the first thing you need to do, identify your negative exponents. I have 3 to the negative 1st, and then I have 2 other sets that have a different base of 4. I'm going to rewrite my fraction bar. I do have a positive 3 to the 2nd power, so I'm going to rewrite that because I'm not moving it. I need to move the 3 to the negative 1st power up, so it becomes 3 to the 1st power. I need to move 4 to the negative 6 down to the denominator, and 4 to the negative 5th up to the numerator. Okay, now let's simplify the denominator. 4 to the 6th, there's just that one term. I'm going to rewrite it. In the numerator, though, I do see 2 things that I can combine. I have like bases of 3. If I'm multiplying these 2, I add my exponents, 2 plus 1, so that gives me 3 to the 3rd power in the numerator times 4 to the 5th. Last step, I am dividing with like bases of 4. So 3 to the 3rd is still in my numerator, times, since I'm dividing, I subtract my exponents. 5 minus 6 is negative 1. So therefore, my final answer is going to have to be 3 to the 3rd, and I'm going to have to move that 4 to the negative 1 down to the numerator to be positive, so it's just going to be 4. If you put 4 to the first power there, that's fine, that's the same thing. Make sure you've corrected any of the work that you got wrong. And then lastly, try this one. Okay, so again, identify your negative exponents. I have 2 negative exponents with a base of 2. And I have another negative exponent with a base of 6. I'm going to rewrite, and I also see right here, 6 to the 0 power, that's really just 1. So I really only have one term, one number that I can rewrite. It's positive. 2 to the third power stays down there. So I'm going to move 2 to the negative second down. And I'm going to move 6 to the negative second down. So it's positive. And then lastly, I have 1, 2 to the fifth power. That moves up. I have nothing else in my denominator nothing else in my numerator because only one term can move up, and both of them in the numerator already went to the denominator. Simplify. Can't simplify anything in the numerator. I have bases, same bases of 2. We're multiplying, so I add my exponents. 3 plus 2 is 5 times 6 to the second power. I have like bases of 2. I'm dividing. So I subtract. I get 2 to the 0 power, 5 minus 5, subtract my exponents, 6 to the second power. Remember, yes, this is correct. However, 2 to the 0 power, anything to the 0 power is 1. So my final answer is really 1 over 6 to the second power. If I were to find the value of that, that would be 1 over 36 because 6 squared is 36. Make sure you have all of these examples and notes down so you can refer to them when you get to your practice.